All right, so in the last lesson we looked at the beginning of 8-104, maximum circuit loading. And now we're going to apply either subrule 5 or subrule 6. So on the board here, I've rated my overcurrent device for 80% rating. So now we have to come and read subrule 5 and 6 and figure out which one we're going to use. So subrule 5 says, where a fuse switch or circuit breaker is marked for continuous operation at 100% of the ampere rating of its overcurrent device, the continuous load, as determined from the calculated load, shall not exceed the continuous operation marking on the fuse switch or circuit breaker, and except as required by item B, shall not exceed 100% of the allowable ampacities of the conductors selected in accordance with section 4. Or B, shall not exceed 85% of the allowable ampacity of single conductors selected in accordance with section 4. So A is for 3-conductor cable per se, and B is when we're using single conductor rules based on 4-004 subrule 1A. Not B, which is what I got written on there. So we come down to 6 because I've marked the overcurrent device at 80%. So when we look at 6 here, it says, where a fuse switch or a circuit breaker is marked for continuous operation at 80% of the ampere rating of its overcurrent device, the continuous load as determined from the calculated load shall not exceed the continuous operation marking on the fuse switch or circuit breaker, and, except as required by item B, shall not exceed 80% of the allowable ampacity of the conductor selected in accordance with section 4, or B, shall not exceed 70% of the allowable ampacities of single conductors selected in accordance with section 4. So, single conductor cable, if we were using the single conductor installation method, which we're not, here we're running a 2-conductor tech cable, so B does not apply. So we're going to be using A. So here, students, what we need to know is in table A, which tables apply, and we're using B, which tables apply. And it applies to both subrule 5 and 6. So in A, it's really referring to tables 2 for copper and 4 for aluminum. And in B, it's referring to tables 1 for copper and 3 for aluminum when you're using single conductors. All right? Because all it does is, in A, is refer you to section 4. Then you got to figure out, based on 4-004, which tables you're applying. So we know we've got an 80% rated equipment. We know that it's subrule 6A. So if we go to section 4, and we're using tech, and it's copper, we're in 4-004 subrule 1. It says the maximum current that a copper conductor of a given size and insulation is permitted to carry shall be as follows. A, single conductor metal sheath in a free air run with cable spacing not less than 100%. We're not using A. We're down at B. 1, 2, or 3 conductors in a runner raceway, or 2 and 3 conductor, except as indicated in item D as specified in table 2. We go to table 2. Now, we also have the termination temperature rule that we would have to apply. So this switch is marked at 75 degrees. And all your circuit breakers are usually, well, I can almost practically guarantee you that 100% that they're marked at 75 degrees. Now, how we test you in the classroom and in the classes is based on the rule. If the equipment is not marked, you have to follow the rule. If the equipment is marked, you are stuck in that temperature column in the table that you select the conductor. So if we look at the table here, we have in the 75-degree column, number 10 is good for 35 amps. And number 8 is good for 50 amps. Now, we already know that we need number 8 to meet the voltage drop requirements here. Because we did that earlier. Number 8, it met the voltage drop requirements in the last calculation, so we know that. We are in the 75-degree column, so we've selected conductor, we've applied this rule, we've applied that rule based on the marking. We applied the voltage drop rule, and now this is our final thing. We got to select the conductor. The number 8 is good for 50 amps in the 75-degree column. And this rule says, well, we can only load the wire and the cable to 80%. So let's just go back there and read that again, because it's critical that you get this. It says right here, where a fuse switch or circuit breaker is marked for continuous operation at 80% of the ampere rating of its overcurrent device, the continuous load is determined from the calculated load shall not exceed the continuous operation marking on the fuse switch or circuit breaker, and except as required by item B, shall not exceed 80% of the allowable ampacity of the conductors selected in accordance with section 4. So we selected number 8. It's good for 50 amps, and I can only load it to 80%. So we'll do the math. So 80% of 50 amps is 40. Our load current is only 31.25 amps. So we're good. Not only do we meet the voltage drop requirements, we've met the for the rating, for the 80% rating of the conductor. Now we got to select the overcurrent device. We'll look at 14-104. Because it applies to this rule, it says where a fuse switch or circuit breaker is marked for continuous operation 80% of the ampere rating of its overcurrent device, the continuous load from the calculated load shall not exceed the continuous operation on the fuse switch or circuit breaker. So that breaker, we only can load it to 80% as well. Well, it says here, the rating or setting of the overcurrent devices shall not exceed the allowable ampacity conductors they protect, except where a fuse switch or a circuit breaker having a rating or setting of the same value as the ampacity of the conductor is not available. The maximum calculated load or known load is in accordance with the rules of Section 8. The ratings or settings given in Table 13 shall be permitted to be used within a maximum value of 800 amps. Go to Table 13. Let's take a look at this 40 amp circuit breaker here. I can only load it to 80%. So 40 amp breaker, I only load it to 80%. The maximum continuous load I can hook to that circuit breaker is 32 amps. My continuous load is 31.25. It meets the requirements. 40 amp breaker, number 8 wire. We've met the requirements of all these rules. Okay? That's how we do it.